Hi, in this tutorial we're going to look at trigonometry identities and how you can easily prove them without having a problem. Basically, trigonometry identities, they resemble a state of balance where the left hand side is exactly equal to the right hand side. Four basic families of trigonometry functions that you should know: the Pythagorean group, standard identities, the double angle formula, and the addition formula. Now, looking at the Pythagorean group, cos squared theta plus sine squared theta is exactly identical to 1. Meaning, if you substitute theta with 90 degrees, you are always going to get 1. Even if you try to substitute with 0 or 45 or 180 on both cos and sine, you always get 1. Two, 1 plus tan squared theta is exactly identical to secant squared theta. Secant squared theta. 3, 1 plus cotangent squared theta. 1 plus cotangent squared theta is exactly identical to cosecant squared theta. Cosecant squared theta. These are the Pythagorean. The standard identities. Tan theta is exactly identical to sine theta over cos theta. Two, cot theta, which is cotangent theta, is exactly identical to 1 over tan theta, which is also exactly identical to cos theta over sine theta. Where did I get this? I know that tan theta is exactly identical to sine theta over cos theta. I can say 1 over tan theta is equal to 1 over sine theta over cos theta. If I solve this, I'm going to get cos theta over sine theta, which is exactly identical to cot theta. 3, cosecant theta is exactly identical to 1 over sine theta. 4, secant theta is exactly identical to 1 over cos theta. To easily remember the last 3, the standard identities, let's say for example cotangent theta, I can count 3 letters starting from C. I say 1, 2, 3. Then T stands for tan. Now I can say 1 over tan theta. And also for cosecant, I can say 1, 2, 3. Then S stands for sine theta. Then I will say 1 over sine theta. For secant, I will also count 1, 2, 3. Then the third letter stands for cos theta. I will say 1 over cos theta. And that way you can easily remember them. Under the double angle formula, which means we are doubling the angle. For example, sine 2 theta. Sine 2 theta is exactly equal to 2 cos theta sine theta. 2. What about the doubling the angle of cos 2 theta, which is exactly identical to cos squared theta minus sine squared theta? I already know from the Pythagorean theorem that cos squared theta plus sine squared theta is exactly identical to 1. If I move sine squared theta to the other side, I'm going to get 1 minus sine squared theta is exactly identical to cos squared theta. I can substitute on cos squared theta, and this is going to give me 1 minus 2 sine squared theta. Also, if I do that on sine squared theta, I'm going to get 2 cos squared theta minus 1. 3. What about doubling the angle of tan 2 theta? Tan 2 theta is exactly identical to 2 tan theta over 1 minus tan squared theta. These are the double angle formula. Addition formula. Sine A plus or minus B is exactly equal to sine A cos B plus or minus cos A sine B. Then cos A plus or minus B is exactly equal to cos A cos B minus or plus sine A sine B. 3. Tan A plus or minus B is exactly equal to tan A plus or minus tan B all over minus or plus tan B tan A. Let's do an example. Let's say we are given prove sine theta over 1 plus cot squared theta is exactly identical to sine cubic 3 theta. I can write LHS, meaning I'm starting from the left hand side to the right hand side. So sine theta over 1 plus cot squared theta is exactly identical to sine theta over 1 plus cot squared theta. But I know from the Pythagorean group we did earlier that 1 plus cot squared theta is exactly equal to cosecant squared theta. I can substitute here with cosecant squared theta. Cosecant squared theta. Cosecant squared theta. Now I can write sine theta over cosecant squared theta is exactly identical to sine theta all over. From the standard identities, we know that cosecant squared theta is exactly equal to 1 over sine squared theta. I can now substitute 1 over sine squared theta, which is exactly identical. Sine theta times sine squared theta over 1, which will give us sine cubic theta. Sine cubic theta. This is what we have been asked to prove. I have arrived at the right hand side.